RADAN 7 is what we'll be using today for data processing and all of our exports. So we'll go through one process from start to finish, and then I'll show you some other data that we can look at annotating. So first thing is first, always in RADAN, what you're going to want to do is set your source directory. This is an important step because it's telling RADAN where you're going to pull your files from. It's also determining where your files will get saved. If you don't select this, you're able to navigate anywhere on your computer to find the data that you're looking for. But when I save my data, it's going to automatically be put to whatever folder is set here. So you might not realize quite where your files are ending up. It's best practice to change this source directory to whatever folder you're actively working in. If this window is not open when you open your RADAN, you can access it by going to the Home tab and opening your global settings. So if I click that off, it might look like this when you open your RADAN. If you click global settings, this will pop up for you. So I'm going to go into my source directory. I just double clicked here. You can also hit the 3 dots over here. And I'm going to navigate to this Idaho DOT folder, which is the folder that I collected in Nashua. So I set that as my source directory. And now the first step that I'm going to want to do is open up my metal calibration file to create that .czt, which is the cal file that will end up calibrating my raw data. So I'm just going to go to open. You can either click it here, or you can go to the G tab and hit open here. And since I set this folder as my source directory, it's automatically just opening it up when I select open. So in the case of the files that I have here, we were collecting 2 channels at once. One of the channels, or channel 1 rather, was our 2 gigahertz data. Channel 2 was our 400 megahertz data. And then we have the metal plate calibration. We only had the metal plate under channel 1, which was the 2 gigahertz, because you don't do a metal plate calibration for lower frequency or 400 megahertz data. But because we had both antennas hooked up, the system collected a file for both anyway. So the only one that we actually care about is the metal plate cal file from under our 2 gigahertz antenna. This one we could delete if we wanted to. It doesn't really mean anything to us. It was just a static collection from the 400 megahertz. So I'm going to open up the metal plate file just by double clicking. And you can see that we've got 2 tabs here, our first tab and our second tab, and it just automatically opened both. The reason it spits out 2 tabs is because for every file, so I'm just going on to my actual desktop where I have this data saved now. For every file, you have 3 file types. One is a DZG, so that's our location information. If you aren't using GPS, you won't have a DZG, but you will be using GPS in your case. A DZT, which is our raw data, and then a DZX, which is going to be any processing steps that we applied on the system. And the DZX is actually just a text file that you can see here. So it's going to tell RADAN what it needs to do to our raw data to reflect what we did on the system. So those are our 3 file types. So when I opened my file in RADAN, it's first showing me our raw data, so that DZT file before the DZX or the processing file was applied to it. The second file is the raw data with our processing applied to it. So this is the one that we're going to want to use. The main reason you can tell this is the one you'll want to use is because our first reflection here from the ground surface is in a black, white, black pattern. So we get this kind of Oreo pattern here. Our other data is going to be flipped. It'll be white, black, white. When I see this, I know that that means that our custom filter has not been applied yet. When the custom filter is applied, which is, it happens on the actual SIR 30. And again, that custom filter is a filter that we create in-house for every single 2 gigahertz antenna that goes out. And it's specific to that antenna. So before the custom filter is applied, you'll see the white, black, white color scheme. When it is applied, you'll see the black, white, black. If you ever are unsure about this, you can click on a file and go to file header up here. And that's going to pull up any processing that's been done to the file. It'll pull up all of the parameters and date of collection and what system you used and things like that. And we can see in our processing history here, all that's happened is this position correction that we applied on the system. There's no custom filter mentioned here. If I go to the other tab, I'm going to see that we have a position correction, a range gain applied, some filtering, and then FIR filter design custom. So that's our custom filter. So if you ever are confused about which one you should be working from, just look at that file header and you want whichever one has that custom filter applied. It'll be the second tab typically, and it will have this black, white, black pattern. So we're going to move forward with this metal plate file, which has our custom filter applied. I'm just going to X out this first tab. We don't need that. And this part's very easy. We're just going to go to the RoadScan tab here, and we're going to go to horn calibration. When I click horn calibration, I get this window on the left. Automatic mode can be left to yes, and I'm just going to hit OK. And it'll do everything it needs to do. It is now spit out this new tab with this tiny, tiny file that's only a couple of scans long. This is our .czt file, or our calibration file that we're going to use to calibrate all of our data. And you can see it says .czt up here. So once we go through that process and we have our CZT created, we're kind of done with everything here. So I'm just going to X out of everything. Now we can open our actual data file. So I'm going to hit open, and Idaho 001_1. So again, channel 1 was our 2 gigahertz data. Channel 2 was our 400 megahertz data. So we actually, when we collected this data, had the system save the channel 1 and channel 2 as separate files. That's not always the case. I think I have some that we can have both. So if you don't export it as 2 files, when you open your data, it'll look something like this, where you have both your channel 1 and channel 2 as 1 file. I like to process them separately, especially if we're working with a 2 gigahertz and a 400 megahertz, because the processing steps for both channels will be different. So when we exported our data, we exported it as already split channels, so we didn't have to go through splitting these in RADAN. But if you forgot to do that and your data was brought in as combined channels like this, you can go to the G button, save as, and then RADAN file split channels, and that'll split them for you. It'll ask you what you want to save it. So I might just write split. And then in that folder, it'll show you A and B for your 2 channels. But we already did that on the system, so I don't have to go through that step. So I'm just going to open channel 1, which is our 2 gigahertz data. All right, same thing as last time. We have a raw data channel and a channel where our DZX has been applied, which has our custom filter. And we're seeing on our first one, white, black, white. You can see it. White, black, white. On our process, we're seeing black, white, black. So the processed one is what we want. It's that second tab. Going to get rid of our first. And then we can apply our calibration file that we just created at the last step. So we'll go to RoadScan, and then basically you can just work your way down this processing section here. So the last step that we did to create the CZT was using this horn calibration button. The next one that we'll use is called reflection picking. In our reflection picking tab, or processing window rather, it's asking, how do you want to select your cal file? If you leave this to auto select, it's going to look in the folder that you're connected to in your global settings as your source directory and pick whatever CZT file is in that folder. Depending on how you manage your files and kind of organize things on your own computer, that might be okay. I like to change this to user select, so I can physically select the correct cal file just to make sure that the right one is being applied. So I changed that to user select. I'm going to hit the 3 dots right here to search for that. And we're in our Idaho DOT folder. Notice that it's showing me an empty folder and it's showing me this proc folder. All it's looking for right now are CZT files. So it's not showing us any of our other files in the folder. And this proc folder is a folder that gets created by RADAN when you start processing your data. It's where all processed data is going to get dumped into. So I'm going to go into that proc folder, and now we can see our CZT in here, which is that calibration file that we want. And I'm going to double click that to select it. And then we can leave automatic mode set to yes here. So all I did was change this cal file method to user select, found the file, and I'm going to hit OK. And we got this whole process opened by hitting the reflection picking processing button. I'm gonna hit OK. And it's gonna run through that process. All right. So now we have our processed data file here. We don't really need this tab anymore. If you like to just have one thing open at a time, you can close it. And now we have our process data. We also have this window that's popped up. This is our depth pane. So as we start selecting our layers, we'll see that information reflected down here. And I have this whole processing side window opened that isn't really necessary to be opened. So I'm just going to go to the Home tab and unselect that to give us a little more space here. First thing is we want to be able to see our data a little bit better. So to do so, we'll want to increase the gain, which is kind of like turning up the volume or the contrast on our data. What it does is basically artificially increases the amplitude of our data, so it's a little brighter on the screen. So there's two ways to do that. One way is to use the display gain function up here, and we're on the Home tab. You can use this drop down and increase that gain number just to brighten things up. Other thing you can do is right click on your data, go to display gain and choose a number here, or you can type in a custom value down here. So I'll try like 20. That looks pretty good. I can scroll using this bottom bar to look at all of my data. I can also move my cursor around in the data, and as I do so, you can notice on the bottom bar here, I'm getting latitude and longitude readings. I'm also getting an elevation value, and I'm getting the distance along my scan and how deep my cursor is. So as I move along, those will all change on that bottom bar. Another thing you can do to enhance the visibility of your data is to go to the Home tab and play with some of these color X forms. So that's just impacting the spread of the colors. That one's a little too bright for me. I'll probably stick with LM12 where I'm at. And now we can see our data pretty clearly. It is sort of messy data. The area around our building where we scanned, there are a lot of kind of tightly spaced utilities, and there are also a lot of manhole covers. So where you're seeing these really kind of like bright blips right on the surface and no data below it, that's where we went over a manhole cover. Since it's metal on the surface, it actually prevented the radar energy from going down into the ground, which is why our layers kind of break anywhere that it's under a manhole there. You can also see the surface metal kind of repeating at deeper depths. That's because the energy is just going to hit the metal, bounce back up to the system, bounce back down, bounce back up, and keep kind of ringing and bumping between the two. So you will likely notice that there are other tabs in your RADAN other than just this RoadScan tab. When we're doing 2 gigahertz data processing, though, it's important that we don't really run any additional processing steps other than the metal plate cal and then applying that cal to this data and increasing our gains or changing our color X form, because the system's doing a lot of complex math across this whole file when it applies that cal file. If I go in and do additional like filtering or background removal filters or things like that, it's going to totally mess up that math that's happening on the back end, which means that our depth picks aren't going to be accurate anymore based on that cal file. So when we're using 2 gigahertz data or processing 2 gigahertz data, it's important to not run any additional kind of filtering steps. At this point, we would go ahead and start annotating some of our layers here. Since this is kind of a messy one, I'm going to open up a different file just to demonstrate the tools a little easier, but we can come back to this later if folks want to. But that's the main processing order of operations. Horn calibration to make your .czt file, that metal cal file. Then you apply that cal file to your raw data using the reflection picking tool. And then this layer interpretation button exists. The goal of this button is to have the software annotate and trace your layers for you. It doesn't work super well, so I would err people away from using this function. But if you find that it works for you, go for it. Basically, all that you do is hit the layer interpretation button, say the number of layers that you want it to look for, and if there's a minimum depth before it encounters that layer, and then you can hit OK, and it's going to apply layer picks across your whole profile. So you can see here, it did a decent job, and we're seeing those picks reflected in the depth pane below. There are some areas it kind of got off track, like where it put some picks in up here. But overall, it wasn't, and like up here. Overall, it wasn't terrible. So that is a tool that you can use if you find that it works for you. Areas where it gets like this, where we had a solid layer and then we kind of lose it, I would say don't apply picks just because you think the layer should continue there. Really just try and follow what you're seeing in your data. Don't kind of make up points where there isn't information. So that was just going through our processing in the processing window of the RoadScan tab. So I'm going to close these out and just open up a different file quickly. Before I do so, I'm going to go to the Home tab and change my source directory by going into global settings. And this global settings button will only be available when you have no files open. If I have a file open, that will be grayed out. So you can see now it's unavailable. So you need to have your files closed prior to using this. I'm going to change my source directory quickly to another data folder. I'm going to open up a file here, which we might have to split. Yep, we do. Okay, so I'm going to split these files. This is another data set where we have 2 gigahertz data on top and 400 megahertz data on the bottom. If someone gave you data and you weren't sure which was which, you can always, again, go into that file header. Right now, you can see that in the channel information section, it's showing me the information for channel 1, which is this top channel. If I want to know what the bottom channel is, I can just click in and change that to channel 2. It's showing me this is a 400 megahertz antenna and all the collection parameters for that. So you can toggle between channels that way in the file header section. So I want to split these channels. I'm going to do that really quickly. I'll close out this first tab, which is the raw data. I don't want that. And I'm going to keep this one open and go to the G button, save as, RADAN file split channels. It's asking me what I want to name it, so I'm just going to write split here and save. So those should be exported now. I can close this out, and then I'll go ahead and open up that file. So this is our one data file. It created this proc file because I just ran a processing step by splitting those channels. So I'll go into proc, and now I see my original file, split A, which will be channel 1, and split B, which will be channel 2. So I'm going to get split A, which is the 2 gigahertz. In this file, something that we'll see that we didn't see in the last data is that we have some user marks. So there are some dashed lines in the data that were put in while they were collecting. In this case, the dashed lines represent the start of a bridge deck and the end of a bridge deck, and everything in between those is just kind of regular highway. So I'm going to go through the same process. In this data set, I have the calibration file already created in my folder, so I don't need to go through the turning the metal plate calibration file into my CZT. So I'm just going to go to RoadScan. This step is already done. I already have that CZT in my folder, so I'm going to go straight to reflection picking. I'm going to change this to user select again, and then find my cal file, which I know I'm in the right folder, and it's in my proc folder, and here it is here. So I'm going to open that and then hit OK. All right, so we have our calibrated data now over here. I'll do the same thing as last time where I want to increase my gains. Might do that a little bit more. Kind of want it somewhere in between those two numbers. 30 seemed a little bright and 20 seemed a little dim. So I'm going to go to custom and type in 25. And I'm getting this by just right clicking on my data. So in this case, we're seeing two layers. We have this upper layer here, and then this second layer here. The areas that are bridge decks we can now see are really bright and high amplitude. That's because they are full of metal reinforcement. So we're getting a lot of metallic reflections in these zones, which is why they just look like these big bands of bright reflections. We're going to go ahead and start picking our layers. You can do that in the RoadScan tab in this 2D interactive section. So this whole kind of zone right here. Right now, our picking tool is disabled, so I'm just able to go around with my cursor, kind of click whatever I want. There are 1, 2, 3, 4 other options for layer picking here. We'll just kind of go through all of them. An important thing to note for all of them, though, is that whatever your focus is set to here, right now it's layer 1. Whatever that's set to is what layer you're going to be adding or deleting points from. So if I have layer 1 selected and I start adding points, those are all getting classified as layer 1. If I change my focus to layer 2, now all of these points are getting classified as layer 2. If I have layer 2 selected and I decide I want to go in and delete some points from layer 1, it's not going to allow me to delete those because layer 1 is not set as my focus. So whatever this focus is set to means that's the only layer that you can add and delete points from. So if I wanted to delete my layer 1 points, I could go back to layer 1 and then go through and delete those. So focus is a really important thing to pay attention to. The other important thing to pay attention to is your pick polarity. Pick polarity is right here. So the default is for it to be set to positive. When it's set to positive, that means that within your cursor range, so if you can see my cursor right here, it's 2 vertical black bars. Within my cursor range, wherever I click, it's going to look for the highest amplitude or strongest reflection that is positive amplitude. So that means in our scan data, it would be a large peak to the right. If I change this pick polarity to negative, within my cursor click area, it's going to be looking for the strongest negative amplitude reflection or the biggest peak to the left in that search width, which is right below it. Our search width is by pixels. So if I have this set to positive, that means it's going to be looking for that white band because we're using the color table grayscale number 12, where black is left on the left side for negative and white is on the right side for positive. So if I have my pick polarity set to positive, it's going to snap toward anything that's kind of white banded. If I have it set to negative pick polarity, it's going to snap to the black band. So in this case, in looking at these layers, it looks like this top one, the most prominent band is this black band. It's white, black, white. So the black band is what's causing the reflection. On the bottom here, that's flipped to be black, white, black. So when I'm tracing this upper layer, I'm probably going to put my pick polarity to negative to snap on this black center band. When I annotate this layer, I'm going to switch it to positive to snap to the center band of this bottom layer. All right, so first tool that will kind of investigate, I'm going to make sure my focus is back to layer 1. My pick polarity, since we'll trace this one first for layer 1, I'm going to make that negative. And we'll just use the single point tool first. So with the single point tool, you're going in and clicking with your left mouse click, and it's just going to point a single point in my cursor. If I want to delete these points, I can center the cursor over one of the picks and then right click, and it's going to delete it. So in the sense of your toolbox, this is like the really, really skinny, only a couple of little hairs kind of paintbrush for like fine detail kind of stuff. Not really effective if you need to cover a whole area. But if you're just annotating little portions or filling in gaps or something like that, this single point tool, it's very accurate and kind of intentional, but it's not really effective for covering a whole length of a file. So that's our single point tool. Left click puts a point in, right click takes a point out. The next tool below it, the select block tool. This gets you a little more bang for your buck. So I'm going to select it, and then you can drag your mouse and draw a box over your data. I'm going to change my colors really quickly just so you can see that box a little better. So I'll go to the Home tab, Color Tables, and then I'm going to pick number 22, which is still a linear color table. So it's the darker kind of weird brownish color on the left, and then this teal on the right-hand side for positive. Just makes it a little easier to see this gray box. So for the select block tool that we're using, I was able to just draw this box. I can drag it around and place it over my data, and I can make it kind of any shape that I want. And then once I am happy with where it's placed, I can right click and hit add points. So it's now just added all these points in really quickly over my layer. It looks like I made the box a little too big and I got these secondary points at the top. Let's say I just want to delete those. I can highlight them with the box, right click and hit delete points. So now I've traced this layer really quickly and in a fairly targeted way. If I wanted to do that for the layer below, again, instead of tracing the black center layer for a negative reflection, it's now a white banded reflection. So I'd switch my polarity to positive. I'd switch my focus to layer 2, and then I can use the select block tool again to outline where that layer is. And then I'm going to right click, add points. If I wanted to, I could kind of make this block smaller and erase any outliers that way. So I could do it kind of like this. Right click and delete points. Or I could go in with my single point tool and just right click over any points that seem like they're not in the right place. These up here for sure are not in the right place. So that's kind of using a combo approach to the two tools. Another option we could use in our picking is rather than select block, select range, which largely does the same thing as select block, but it's going to go from the start of your profile all the way to the end of your profile. So I could hit select range. Let's say I want to focus on finishing my layer 1 pick. So I'll change that to layer 1. I'll change the polarity to negative again. And then I'm just going to click on here and I'm going to put it at the right height-ish. You might want to scroll and look down your profile and make sure that the depth of that layer is not changing a lot, because if so, this isn't a really good tool to be using, but it looks pretty static. So I'm just going to right click and hit add points. Again, it looks like it got some outliers at the top there, so I can do the same kind of thing where I just tighten it up along those outliers and then right click and delete those. And now that looks pretty solid. And I just traced the whole layer fairly quickly. So that was the select range tool. Again, kind of same thing as select block, but it goes from the start to end of the profile. I'm going to unselect that. The other tool that we can use is our easy tracker. And I would say easy tracker is probably the tool that people use the most, because you keep kind of good control like you do with the single point tool, but it's a lot faster. So I'll use the easy tracker on our second layer here. And something to note about these layers is that they are hierarchical. So layer 1 has to be shallower than layer 2, which has to be shallower than layer 3, etc. So for that reason, some people start picking with layer 2 and then go to layer 3 and layer 4, just in case they find a shallower layer later. But you're also able to change the classification of layers after you pick the points for them, which I'll show you how to do in a second. But just keep in mind that layer 1 has to be the most shallow, layer 2 under that, layer 3, and then layer 4. All right, so let's go ahead and use the easy tracker. This is a positive polarity reflection with that white band. So I'm going to switch it to positive, and I need my focus to be layer 2. So I'm going to select easy tracker. When I select that, this start and stop button get highlighted. So I'm going to hit start, which means I'm going to start annotating, and I'm just clicking along this and it's filling in the points in between. The last one got a little crazy. If I right click, it'll delete everything from that last batch of points. If you click more closely together, it's more accurate. If you click further apart, you tend to get some more outliers. So right now I've encountered this bridge deck. I don't want to go through the bridge deck because it's something totally different. It's not even showing me layers. I'm just getting reflections off of that reinforcement. So I would hit stop. I'd hit start again, and then I can start on this side. And you can try and go pretty far apart, but it tends to get a little messier. So keeping it semi-close. If you have a really well-defined layer, it can go for pretty long spans. But if it's kind of a duller or less visible layer, you want to keep your clicks kind of close together. So I can stop, hit start again, and keep annotating along here. And again, as I'm doing this, we're getting all of these points populating down below. Any area where the red is really like pulling up to the top, that doesn't mean red points are getting plotted as more shallow. That just means there was a part where we didn't put any yellow points in. So like right here, we have red points, but there aren't any yellow points. So it's just showing it as going all the way to the top, even though it's not. So don't be alarmed by that. We could keep going along our layer here until the end of our file. So I'll probably hit stop again here. I've kind of lost my layer. I'll hit start again and keep it up on this side. All right, stop. So now we've annotated all of layer 1 and layer 2. Let's say at this point, I decided that there actually was a shallower layer than layer 1 that I care about, and I need to change all of layer 1 to actually be layer 2 and all of layer 2 to actually be layer 3. You can use either the select block or the select range to do that reclassification. I'll probably use the select range just because I annotated all the way from the beginning to the end of my profile. So I'm going to change layer 2 to be layer 3. So I want my focus to be layer 2. That's the point. Those are the points I'm trying to change. I'm going to do select range and make sure that this box covers all of my points, which I might just do a quick scroll and make sure it's in the right place to catch everything. Looks like it needs to go a little higher here, and then that should be good. So I have the select range tool out. You would do the same thing with the select block tool. It's just not going to go from the very start to the very end of your profile. You might have to work in chunks. And I'm going to right click, and rather than add points or delete points, I'm going to select pick mod options, pick modifying options, change pick ID. So it's saying change from layer 2 to layer 3 or 5, 4, 5, 7, whatever, any other layer. So I'm changing all of my layer 2 points to actually be classified as layer 3. I'm going to hit OK. So now they're all reclassified. I could then do the same thing to change layer 1 to layer 2, and then I could use layer 1 for whatever shallower layer I might have found. So we saw the color change here because it got classified as a different layer, and now it's green instead of red. We haven't really looked much at our table window down here. You can open this by going to the Home tab. If it doesn't just pop open automatically, but typically it does. If you don't see it open, you can go to the Home tab and select tables here. But we have layer depth tab here, a layers tab, and layer pick details. So in the layers tab is where we have our color classifications listed. So layer 1's yellow, layer 2's red, layer 3's green. The size of the pixel, so how big are the dots that we're putting on it. And then some other fields here that we'll get into a little later. But you can actively change the names of these layers. So if you know layer 1 is gravel or something like that, you can actually change it to be called gravel. And then in the RoadScan tab, as your focus, you'll see gravel listed rather than layer 1. So if you have that information, like let's say you did take a core and you saw the different layers that exist in your matrix, you could actually name them some material rather than layer 1, layer 2, layer 3, that kind of thing. I'm just going to change it back to layer 1. You can also change the colors here. You wanted layer 1 to be green and layer 3 to be brown or something, whatever you wanted there. So those are our 2D interactive tools that we're primarily going to be using. This is really the only processing that you'll be doing with your 2 gig data is those horn calibration and reflection picking processes, and then going ahead and actually picking your layers. Let's say that you had a core. I would say if you are collecting cores and you know the location-ish of where they will be collected while you're doing your survey, if you go ahead and put a user mark in for that core location, you'll be able to determine where along your data profile you should put in your core information, or even if you write it down in your notes, like a certain mile marker or something along the road, so you can tie it into where along your profile later that core should go. So let's say we, in our notes or from a user mark or something, knew that we took a core at 7,800 feet along our profile, and we want to tie that information into our data here. To do that, you can use this ground truth tool. So I'm just going to click that, and the cursor that I have is just going to be my normal cursor now. I'll go to 7,800 feet, try and line up my cursor the best I can and click in. So it's asking me now at this core, what was the actual depth to the base of layer 1? So what was the measurement from 0 to the bottom of layer 1 here? And let's say the depth to layer 1 was 2 inches or something. So when we're talking about our layer depths, what we're seeing in our data is the reflection from these interfaces. So when we're tracing layer 1 in our data, we are tracing this layer right here. That's what we're calling layer 1. We're putting points along it in our data. So when you're taking your core information and comparing it to this, when it's asking you the depth of layer 1, that's really the base of whatever this first layer is. So the top of your second layer is really what we're saying when we're getting our layer 1 picks in, because we're picking along that interface. For our layer 2 picks, when it asks you for layer 2, the measurement it wants you to put in is the measurement from ground surface to this interface. So really the base of your second layer. So it gets a little confusing. You need to kind of actually think about it with what the core looks like versus what your data looks like. So the measurements that we're putting in here is like the base of layer 1 and then the base of layer 2, etc. So for layer 1, we're saying that this point where we've picked reflections, so the bottom of whatever this fill layer is 2 inches. If I tell it to lock my location, it's going to allow me to click into the same area and it will ask me how deep layer 2 is. So I'm going to hit OK. And I put a little black dot here, you can see. So I'm going to go in again and click. And now it's saying what's the depth to the bottom of layer 2. And I'm going to call that 5 inches and hit OK. So we can see that the point that I put in here is actually shallower than where our picks are. So it's going to want to calibrate. We will probably want to calibrate our data to this core. And these are just arbitrary values. So it's really far from what we're seeing in the data. Theoretically, your core should not be that different from what you're seeing in the data. But you can see down here too, the actual pick depths are not the same as our core points. If I wanted to base the data surrounding this core off of our core depths, I can do that by going into the select block tool and kind of tracing around it. And this is up to you all how big of an area outside of a core you're willing to base your depth measurements off of that core, because one core might not be representative for the next like 700 feet or so, or 600 feet. You might say that core is only relevant for like 100 feet on either side. So you can figure out what that kind of radius is. But let's say I wanted to calibrate this data based on my core. I'm going to highlight it with my select block tool. I'm going to right click, pick mod options, change pick velocity, and I'm going to change the velocity calc to our core data. So now we're saying override the calibration you used when we applied our metal plate cal and replace how you're figuring out the velocity, or which is getting us to our depth, by using this core data. So I'm going to hit OK. And that was for layer 2. So now we can see the layer 2 points got dropped down to that black dot on our depth pane. And now let's do it for layer 1. I'm going to right click, pick mod options, change pick velocity, change it to core data, and hit OK. And now my yellow points up here got pulled down to that value. The only changes that you'll see are in this depth pane. That's what it can actively update. RADAN doesn't have the processing power to actively update this image because there's so much variation between scans based on that cal file. So you want to see the change happen down here, not here. But we can see for the radius that I selected on either side of that core, it's pulled all my layer 1 picks down to that level, and it's changed my layer 2 picks too. Okay, so that's pretty much everything for our 2 gigahertz.